So, hello everyone. Thank you so much for coming. Yeah, thank you so much for coming, and thank you for the Wix data science team for hosting us. My name is Yuval. I work for this tiny little startup you might have heard of called Microsoft, and I have a little confession to make. While my esteemed colleagues and the other presenters are all PhDs, or at the very least researchers, and have been doing this for a while, I actually am not a researcher. I rather belong to this team called the AI GBB team. GBB is an acronym for Global Black Belts, and what this means in a nutshell is that we are the team that takes a lot of the research that comes out there from academia, from other companies, from our own research department, and we apply that at customer sites. So we're always on the edge, right, at the edge of what is possible, and we're always pushing the envelope. And so what you see is that most of the GBBs have been doing fine-tuning pretty much since the concept actually came out. So that's probably 2, maybe even a little longer. We've been doing multi-agent systems for quite a while, and a couple of other interesting things. And if you catch me later, I'll be happy to tell you about some of the projects that we've been doing both in Israel and outside of the country. There are about 100 of us all over the world. Okay, so what are we going to talk about today? I'm going to give you a motivating example, but since we're kind of limited on time here, I'm going to just explain it. And if we have time, I'll show you this at the end. I do want to show you some other nice example, which is a little more fun. We're going to talk about just a bit how LLMs work. This community here already knows this, but I do want to do something kind of to make sure that we're all on the same page. We're then going to talk about this concept of structured generation. And OpenAI has been coming out with these truly awesome things, right? The last one was just last week. So it's easy to forget that probably about a month and a half ago, they came out with this idea of structured generations, which means the model can actually output valid JSON. Okay? Wow. I mean, that was amazing for all of us who have been struggling to do this with prompts for pretty much as long as the sun shines, right? Or pretty much as long as there have been prompts. So we're going to talk about this, and we're going to take this idea that OpenAI came out with for JSON, and we're going to extend it. We're going to talk about the ability to generate any format and any kind of output that you want. And if you saw earlier, Lior was talking about, okay, we get these numbers, and then the text. What if we don't want the numbers? Then there's a way to do that at runtime without having to fine-tune the model. And obviously, at the end, we'll summarize and a few questions. Good. So the motivating example is actually something that on one of our projects, we had to count a list of words. So imagine words like yes, no, yes, no, yes, no. And we had to say, okay, the word yes, or we had these questions. Now the question was, does the word yes appear more than 3 times? Does the word no appear less than 2 times? And an LLM would be able to do this, especially the later versions of GPT. And regulators weren't happy. This is a regulated industry, and they wanted this part to be in code. But now this is a multi-agent system, and we have to go through a fair number of agents and actually convert this question into code. So essentially what we wanted to do is have the LLM come up with, for the question, give me the mathematical operator less than, equal, comma, the number, and do that in quotation marks. This, as you can probably imagine, is, well, not incredibly hard, just incredibly frustrating, okay? Because the model insists on doing Lots of funny things like writing explanations and putting the quotation marks in the wrong place and sometimes not coming up with the numbers or the right operators at all. So it was kind of a hassle. And then we did this with guidance. So we'll talk about guidance in just a little bit. Good. So we all know how a LLM works. Okay, so let's just do a quick reminder. We can think of an LLM as essentially a conditional distribution, right? So if we write this in Python, then sampling the next token is like a pseudo function which takes token 1 through token n, that's our context window, and then we put that into the function f, which is just our conditional distribution, and we sample from that distribution. Easy peasy, right? I'm just saying and showing you this because I want to show you where guidance steps into the picture. Good. So now let's talk about the actual guidance system. So guidance is an open source library. You can find it at Guidance AI on GitHub. It is Microsoft sponsored. A lot of the developers are from Microsoft, but it is an open source project, and you can feel free to contribute, open bugs, open issues, and be good open source citizens. So when we do structure generation, the idea is that we intervene in the conditional distribution. That is, we somehow step into the actual LLM and change that function f and tell it, okay, so now I don't want a number, so I'm going to go and take all of the tokens that represent numbers and I'm going to artificially lower their probability. And again, if we do this in pseudo-Python, then notice that we have wanted tokens at the end of the function, and we have a loop. Before our sampling, we have a loop where all of the other tokens, we set them to 0, and we do a uniform probability distribution on the tokens that we want. Quick question. What does this mean? So what are the implications for your LLM when you want to do something like this? Okay, so there's one answer that you have to know the distribution. Okay, so you want to mask. But the implications are that you actually need that access to the LLM's internal state, right? You need to be able to access the KV cache, and you need to be able to modify it. And when you're doing this on something like OpenAI with their servers running on somewhere in the cloud, on whatever data center you choose, then that's not an easy thing to do at all, right? You do not have access to this kind of thing. Which means that when you do this kind of thing, you have to do this on your own LLM. You have to run the LLM yourself, with a small caveat, which I'll show you in just a little while. But the really cool thing when we're talking about guidance is that once you do have that access, you can do some crazy things. And this puts whatever OpenAI came out with pretty much to shame. I mean, you can do so much more. So let's have a look at some of the capabilities. So the first thing is you can improve generation latency. Why is that? Because you don't have to do the sampling, right? You can simply go in, say, this is the token that I want, return it, right? No more sampling. That's one thing. Another thing you can do is, and this is really cool, interleave, control, and generation. So again, looking at this pseudo-Python, notice that now we're asking for a specific number of tokens, and we have some user code. So the idea is you sample, you run some code. You sample, you run some code. Okay, so you're in there already, And you can simply do things with these tokens. You can essentially kind of make, if I want to put it simply, you can actually make this into, if you're familiar with WebSockets, you can make this like one long generation. The context continually updates, and you can do whatever you want. Again, assuming that you have control of the KV cache and you have the ability to go in there, which means you need to host this yourself. Okay, so guidance AI. So guidance is, as I was saying, a structure generation library where the term structure generation here is actually something much bigger and much wider than what OpenAI made it. OpenAI gives you the ability to do JSON. Guidance gives you the ability to do so much more, as we've just seen, and I'll show you at the end. Controlling, obviously, the outputs of any language model. And in fact, it is possible to do some interesting things with OpenAI as well, despite the fact that the model is actually on a server that's not under your control. You're able to work with multiple servers, right? So you can use Hugging Face, you can use Llama CPP, you can use, as I was saying, of course, things that are on the cloud, whether it's OpenAI, Anthropic, or any other common models, everything goes. And finally, I get back to this idea of interleaving control with generation. And actually, the really cool thing that we can say about Llama, about guidance at this point, is that it is beginning to show up on the server side. Specifically, the first sign or the first place where we saw it is that if you're using Model as a Service on Azure and you're using Phi 3.5, if you're not familiar with Phi, it's a set of small language models coming out of Microsoft, highly curated data, but I guess everybody here knows this. And we actually have a server that accepts guidance commands. So you can run guidance on your own machine, and you can connect to the server, and this is just the beginning, right? The more models come out, the more places that you'll have a guidance server actually listening for your ability to give token or to do these things with the conditional distribution. So, okay, I think we have time for the demo after all. So let's go ahead and actually bring this up. Good. So here's an example where we're actually using Llama 3 8B, and we're running this on Llama CPP as opposed to HF. Okay, so we're loading the model. Everything is good. This was actually run on a machine with a GPU. So all the times and the timings that you'll see here are actually quite quick. And as I was saying, this is the problem description. Given a list of words, you want to answer the question, or rather, you want to generate code that answers the question, does yes appear at least 2 times? Does mandatory appear no more than 5 times? And so on and so forth. So let's go ahead and set up our system prompt for that. Okay, as I was saying, we're not, the GBB team works on actual projects, so this is something that we did for a real project, and the prompting here was super important. Okay, we describe the problem, and we begin by doing 2-shot learning. Okay, so we give it 2 examples. The word yes must appear exactly 4 times, so what we want is this text required yes, and we want equals, comma 4 within quotes. Another example, the word mandatory shall appear at least twice, and the word yes at most 5 times. And notice, once again, that we simply translated it. Good. So let's go ahead and actually try this. And for our first example, I'm going to do this with guidance without using all of the fancy capabilities. This is just a replacement for doing direct OpenAI calls. So we have this system area, right? And this is where we give the system prompt. LM is our language model. And using the plus equals operator, we just add to the language model object, and that's essentially adding to the context. Then we have a user area, right? A user context. And this is a Python context, obviously, right? So I'm using the word context here in multiple meanings. And we say, translate the expression that we set here. And finally, we use this operator called gen, which is short for generator, and the max tokens that we want, and this is 50. Now let's see what comes out. And this is GPT-4o. Okay, here's our two-shot, and okay. So the expression, the following words needs to appear 3 or more times, no. So, okay, it got the text correct, it got the operator correct, but the comma and the number are actually outside of the quotes. Okay, and this is the same, pretty much the same annoying problem as trying to generate JSON. Okay, but generating JSON by this time is boring, right? So I wanted to show you something a bit different. Okay, moving on. What happens if we do this with zero-shot learning, right? So we just use guidance again, and notice that over here, we have the system prompt and then the few-shot prompt. And in this example, we're actually reinitializing the language model to be a clear Llama 3, and we're adding just a system prompt. Running this gives us, and by the way, notice that the things in green are actually what the model generated. So this is even worse, right? Because once again, it puts the comma and the number outside of the quotes, which is not what we want, and it also adds its own text. Right? And how many of you have actually struggled with don't print any text other than, just print yes or no, and then it does whatever the H it wants, right? Yeah, so that's a theory I tend to call the angry 12-year-old. It does what it wants, pretty much. Good, and notice that it output a bunch of tokens that I really don't want, and all of this takes time, right? Because this is all sampling. Okay, let's try and do the same thing with guidance, and specifically, we're going to use a feature of guidance called context-free grammars. That is, we're going to set up and we're going to tell guidance to, at this point, print only these tokens, or the only tokens that are possible are these tokens, and now these tokens. And then we're going to do some fancy things. So let's begin by actually looking at the functions. We have this guidance tag, right? This guidance decorator. And we have the ability to print an operator. We get a language model as a parameter, and we want to print just an operator. And notice that we're using a command or guidance function called select. And select essentially does exactly what I showed you earlier. It says, only these tokens are possible. Actually, if we want to be precise, only these multi-tokens, right? Because you can say, now print something that is composed of multiple tokens. But essentially, only these strings are actually possible. We then have another function, which we call number. And here we're using the same gen function for generate. But now we're telling it to generate something based on a regular expression. And finally, we have a function called convert. And notice what we're doing here. And this is where what I was saying about interleaving control and generation comes into play. Because the actual text, right? If you remember, it had to say required underscore yes, right? It had some kind of prefix. So absolutely no reason to let the LLM do it. We can do this ourselves. So this is what we do initially. We add that to the context directly, and now we specify the CFG that we want. Oops, sorry about that. Okay, this area right here. Notice that this is super readable, super easy, and the main thing is the fact that it actually gives me the right answer. So, required no, operator, comma, and number are within the quotes, and the only tokens that I actually had to sample are the things inside the quote. So the LLM was working only where it had to. Everything else I was able to do by myself and get the exact format that I want. Okay, so imagine the time savings and the no need to deal with prompts and to do a whole bunch of really cool stuff. Okay, let's take a look at the other demo, which is doing something, again, pretty nifty. And in this case, we're actually using Azure OpenAI. Okay, so this is the password, all the setup, all good. As you recall, when you use a model that's running on a remote server, you don't have the ability to do CFGs, right? You can't actually intervene into the conditional distribution and change the KV cache and do all of these fun things. So what can you do? So in this case, we're going to do something that resembles a multi-agent system or a question-answer multi-agent system. We're going to have one agent that comes up with questions, and then we're going to have another agent that comes up with answers, and we're going to simply have this agent call that agent and repeat this as long as there are additional questions that need to be asked. This is a prompting technique called self-ask. So once again, we write these functions. So notice that with the follow-up required function, you actually ask, are follow-up questions required? And we use the select function to only allow the words yes and no. So maybe a word of warning at this point. OpenAI does not always respond with yes or no. It might respond with something else, and since you can't control the internal distribution of OpenAI, this might do some crazy things, this might throw errors. But at least at that point, you know that it didn't return the right answer. The solution, you simply run it again, and it tends to do what it should. And actually, yes and no is because I tried this multiple times. I actually wanted it to say true or false. But it would only, for binary questions, it would only return yes or no. OK, good. We play with the model, no problem whatsoever. We then create a follow-up question, which is just a user prompt of follow-up question colon. Then the assistant actually generates a set of tokens that end with a question mark. And now we have another user prompt which says follow-up answer, and that ends with a period. Right? So single sentence, very short questions, very short answers. And you'll see this in the system prompt in a little while. And finally, we have something that extracts the name. And notice that for the gen operator, we have this parameter called name, which takes the generated output and puts that into a separate dictionary on the LM object, so you can actually pull precisely what you need, rather than the entire text. Good, so let's go ahead and look at what we're actually running here. Okay, this is standard prompting. use only short questions and answers, explain all conclusions you arrive at with proper references, so chain of thought, right? And do step by step and those kinds of things. Okay, now notice what we do. We have multiple questions. What is the birth city of the Prime Minister of Israel before the one who was in office when a Palestinian organization murdered Israeli athletes? Okay, so for those of you who don't remember, we just took, I think 2 weeks ago, had the 50th anniversary of the killing of the athletes in Munich. So this is the first thing that came to mind. And now notice how I'm using guidance to actually write the code for this. As I said, normally this would be probably a multi-agent system that would ask questions and answer, and we'd have multiple agents. So we're going to start with a follow-up question. And then as long as the answer to that follow-up, or as long as the answer to is a follow-up question required, as long as that answer is yes, do the following. Create the follow-up question and check if yet another follow-up is required. And just for the sake of being a good citizen, sleep between these calls. Tell you a little secret, Microsoft employees do not get special privileges on OpenAI. You would think we would, right? Good. And finally, we say extract name, which is extract the exact name of the birth city of the Prime Minister of Israel, etc., etc., etc. Good. Notice what it's doing. Here's the question. Is a follow-up question required? Yes. What's the follow-up question? When did the murder of Israeli athletes by a Palestinian organization occur? Follow-up answer. And it tells us the Munich Olympiad, and specifically Black September. Now it goes into the loop, and it asks again, are follow-up questions required? And the answer is yes. And what's a follow-up? Who was the Prime Minister of Israel before the 1972 Munich Olympics? And the answer is Golda Meir. Is a follow-up question required? Yes. What's the follow-up question? Who was the Prime Minister of Israel before Golda Meir? We have Yigal Allon. And the final follow-up question is, what is the birth city of Yigal Allon? And we have Yigal Allon was born in Kfar Tavor, Israel. And our follow-up questions required no, which means now we can exit the loop. And our final answer, without all of the text and all of the garbage around it, is simply Kfar Tavor, Israel. And just for example's sake, I actually left in what the model is generating. Obviously, this could all be running silently. You wouldn't see anything up on the screen, and you would just get the answer at the end. So 4 or 5 lines of code actually allow me to replace what I would normally have to do. Thank you so much.